My name's Dr. Matt Butler. I'm the Associate Dean of Learning and Teaching in the Faculty of IT, and this is going to be a rapid-fire 20-minute presentation. So I'm going to be covering quite a bunch of things. So it's going to relate to a bit about the faculty, a bit about Monash in general, a bit about the courses that we offer, primarily focusing on the undergraduate courses. This is just to give you a bit of a taste and hopefully spark some things in your head about, that's a question I should go and find the answer to, or, oh, that's really intriguing, I need to find out a little bit more. So this presentation is deemed more broadly kind of your future in IT. Why do we call it that? I could stand here and just kind of say, we offer this course, we offer this course, and we offer this course. But I think what is really important is to actually kind of highlight why we think moving into IT is such an important and amazing thing to do right at this point in time, right? The future for technology has never been kind of brighter and more awe-inspiring, to be honest. Here's kind of just 4 things that are driving IT forward. For all of you who are looking for a job at the end of your degree, the amount that is being spent on IT, both infrastructure, systems development, research and development, all of those kinds of things is just kind of escalating at a quite dramatic rate. Worldwide IT spending last year was projected around $3.7 trillion, and we know it's going up and up. And that's a lot because of the important part that IT plays in society, in business, but also the amazing potential still of technology in our everyday lives. And one of those things is artificial intelligence and machine learning. So the idea that computers, they don't replace humans, right? They're going to support us to help better decision making, to solve many of the world's big challenges, right? So that's the role that AI and machine learning can play. And there's so much still to develop and learn around those techniques and those technologies and how they might help us. That again is reasons for this investment and this excitement around technology. Social media obviously is everywhere, with the vast majority of the planet using social media on a daily basis. And then we've got this whole automation of everything. We've got e-banking, e-shopping, e-payment, e-everything. You can whack an E on the start of everything by the seams of it. Talked a little bit about artificial intelligence. Again, I think it's really important to think about these technologies not kind of like, this is the worry of what's going to happen, but the excitement and the opportunity that they bring. For example, here we talk about tracking human patterns. We're talking about smart home devices, virtual personal assistants, fraud detection, all of those kinds of things. And I'll touch shortly on some of the amazing research that many of our staff here at the Faculty of IT do. This notion that we've got data everywhere. So this idea that we're surrounded by huge chunks of data, whether it's business data, whether it's education data, whether it's social data, all of those kinds of things. So how do we look at that data? What does it say? How will it solve some of the world's big problems? Like, how do we use this to tackle climate change or important social issues? Those kind of things. They're one of the things that keeps popping up. And if you've done kind of a job search in any time, you hear about big data and you hear about data science, right? So that is one of the reasons as well. But we don't just have big chunks of data, we have this integration of now information and systems and things like that. So we've got hospitals needing to connect up, emergency services, finance, manufacturing, all of those kind of things. Increasingly, everything is becoming connected. Then we've got robotics. Who knows? You could be kind of catching your self-driving car to uni. So those of you in year 10, maybe 2 or 3 years, you might be getting your self-driving car to uni. We don't know yet, right? So we've got the robotics side of those kind of things, but we also have the machine learning, the artificial intelligence side of things as well. But then we also have the role that robotics can play in manufacturing, in rehabilitation, rescue robots in assisting natural disaster zones, all these kind of things. Why I put these things out there is to say that IT now is lots of different things. It's more than it's ever been before. To the slide that lots of potential students like, lots of parents seem to like as well, around the role that, or the spot that the IT industry kind of plays in industry these days, with it's one of the highest salary averages in Australia. So, and that continues to kind of keep going, especially as we have these roles like data scientists, people who have expertise in AI, other systems development. I mean, everybody wants those people, right? And that's what drives the salary up. So being part of information technology leaves us in a fortunate position, not only because the grand challenges that we have to solve are so amazing and so fascinating, but also that we can get paid pretty well to do that as well, which is really nice. Lots of different types of IT jobs continue to go up. So we've got some of the ones that have been a bit more traditional in terms of web development, computer network professionals as well. The notion of business and systems analysts, those kind of job roles keep going up. Software, apps programmers, those kinds of things. And as I mentioned, the need for things like data scientists and whatnot continues to keep going up as well. So these are some stats that are quite easily available. While more traditional parts of IT continue to be in high demand, there's also these emerging roles that comes with technology that kind of start to come up as well, right? So that, again, that's what's really exciting. It's always important, I think, to talk a bit about why IT at Monash. Monash is one of the group of 8 universities in the country, which means we are very research-led. Right? So I'm a researcher as well as a teacher, and the vast majority of our academic staff are as well. And we think that research-informed education is vitally important. I've just talked a bit about some of these emerging aspects that are coming through. A lot of those need researchers to drive the innovations, and then if we've got researchers who are also educators, that starts to creep in and really inform our education practice. So that's what we mean by world-renowned academics and researchers, and I'll talk a bit more about that in a sec. We've got accredited undergraduate degrees by the Australian Computer Society, so it's not just a bunch of kind of crusty old academics, I guess, saying this is what we think is important. It's also the Australian Computer Society, the peak kind of body in the country that tries to inform what they see as the important aspects of an IT professional, informs our education programs as well. Teaching innovation is vitally important, not just for the Faculty of IT, but also for the university. Teaching and learning spaces are not what you would think are traditional teaching and learning spaces. There aren't really rooms like this. There are flat rooms that hold 30, 60, 90, 120. There's a 180 seat in the round space. There's a 300 and something space, kind of slightly tiered lecture theatre. These spaces are all designed to push people like me to teach in different ways. Gone are the days where every class should be just the wise person at the front. It's about co-creation of knowledge. It's about working with each other, with peers, to kind of deeply understand content. And so as such, we have spaces that kind of drive that. Woodside building for technology and design and education, right? So it's going to be similar to the learning and teaching building, but a dedicated space for IT and for engineering to really drive teaching innovation forward. So it's a really exciting time as an educator to be on this campus, but also hopefully for any student who's looking to arrive as well. The industry experience opportunities that we have as part of the Faculty of IT are huge, and I'll talk a little bit more about our industry-based learning program shortly, but I would say that we're kind of the envy of all universities in the country in terms of the breadth of our industry-based learning programs. I'll talk a bit more about that in a sec. And we are a dedicated faculty to teaching and learning. What that means is we're the only dedicated Faculty of IT in the country. What that is a sign from the university about how seriously it takes this as its own discipline, and it also allows us to get a diverse bunch of technologists, researchers, educators, all in the one group who can then riff off each other and build off each other and work together to create true interdisciplinary kind of strengths as well. And it also means that our outreach to other parts of the university and industry is massive as a result as well. Just to touch on a little bit around why we think our faculty is excellent, I guess, as it were. We're now the leading software engineering research group in the country. Right. So we have a Bachelor of Software Engineering that we teach with engineering, and our researchers are the envy of the country, if not the world, in terms of the research that we've got happening there. We've argued the leading blockchain cryptocurrency research group in Australia. Blockchain is not just Bitcoin, right? Blockchain is a technology that could fundamentally change a lot of the way that the world works in terms of how we can put more trust into financial systems or voting or anything like that, right? So again, this is one of the main areas, technology areas that is growing, and we have arguably, you know, the leading research group in there, which again then will inform our education programs. One of the leading optimization research groups in the world, so if you're thinking about computer science, optimization is a big part of that as well. And we have the largest academic data science research group in the Southern Hemisphere. I've already talked a bit about data science as well. That's the people in the faculty. That's the people who would be teaching you on a day-to-day basis. And that's people, they're the strength that those people have that inform our education programs. So, what can you study at Monash? This is, I said, going to be a rapid fire, just to give you a teaser. With regard to undergraduate degrees, we have a comprehensive degree, which is our Bachelor of IT. And inside that, you'll do one of 5 majors. I'll talk a bit about that in a sec. We have a Bachelor of Computer Science, which is what we call a specialist degree, and where you can specialise in either advanced computer science or data science. We have an advanced honours version of the Bachelor of Computer Science. There is also a Bachelor of Software Engineering. So just a quick bit about the Bachelor of IT. I often get asked what's the difference between Bachelor of IT, a Bachelor of Computer Science, and a Bachelor of Software Engineering. Here is the really short, pretty factually correct, but a bit fuzzy kind of thing around how to differentiate those. I like using Google Maps. It's not a bad example, right? So everyone knows Google Maps, or some kind of maps thing, right? Okay, if I am a computer scientist, what I'm probably solving with Google Maps is how are we doing the routing? How am I going to make sure that when somebody says, I need to get from home to Monash Clayton, I'm going to get them there in the fastest way possible, and I'm going to understand all of the constraints that exist around traffic and around, or the public transport or whatever, and I understand all of those things, and I'm going to do some kind of route optimization to get you there the quickest. That's something a computer scientist might do in there. The next thing is, well, we need Google Maps to run at scale for millions and millions of users on mobile, on desktop, tablets, all those kind of things. We need it to perform optimally. That might be a bit of a software engineering problem, right? We're talking about a big, large-scale system that has to deal with many parts and things, and we're talking a bit about hardware and a bit about software, about making sure that runs well. Right? At scale, it's a bit of a software engineering problem. Interface, we need to make sure the interface is intuitive. That again, it looks good and works well on mobile, on desktop, all those kind of things. That could be a bit of a software development type challenge. Could be a bit more of a Bachelor of IT challenge. That's a very broad stroke way to delineate between the three. So Bachelor of IT, 3 years, ATAR of around 80-ish. When you do it, you do 8 common units and you'll choose 8 that are a major. But business information systems, networks and security, games development, interactive media, or software development. You can mostly do 2 majors as well, right, in terms of your course map, because you also have 8 electives, which is great. The great thing about those 8 electives is that pairs well with other degrees to do a double degree. Right? So I'll talk a bit about double degrees in a second. Bachelor of Computer Science, 3 years, ATAR around 84, 85, roughly. Once you get into computer science, you can then do a bit of a specialisation in advanced computer science or data science. Right, so you get to choose a sequence of 4 or 5 subjects down the stretch. And the kinds of things you'll get into are data scientist, analytics professional, all those kind of things. There is also an advanced version of this with an ATAR of around 95. Select entry, because what we do is we embed research principles and practice throughout your degree. So it's 4 years, and you'll come out with a 4-year kind of honours degree out of part of this. We get you involved with research groups as part of your training as well, right? Because of the ability to kind of give you that real kind of tight research experience, enter score is up because we expect a lot of you. We can only take less students in. But amazingly demanding, but amazingly rewarding as well. But I've talked about industry-based learning. Everyone does capstone. We have a bunch of programs at a faculty level and a university level to push you. The worst thing is when a student comes in, does their work, goes home. We want to get you here. We want to get you into industry team initiatives. We want to get you into peer mentor programs. We want to get you into entrepreneurship programs. These are other reasons why you would come to our faculty and Monash University to study. Talked about IBL Placement. These are all the kinds of organisations that you can be working at. The banks, the major consulting firms, those kind of things. I'll probably just finish with this, which is to say the double degree options that you've got are huge. That is, again, one of the really important things I think that comes from coming to a university like Monash University, is we have 10 faculties and we have a double degree with almost all of them. Because IT by itself is pretty great. IT with another set of expertise or context in which to apply it is incredible, and that's where we're at, right? It's IT in business, it's IT in art and design, it's IT in education, it's IT in engineering, it's IT in science. So the ability to do double degrees at this university, I think has got to be one of the big selling points. There are also scholarships and alternate pathways if you don't get the ATAR score, through Monash College, through TAFE programs, through transfers from other courses.